Hi guys, this is topic 8.2 for AP Chemistry, pH and pOH of strong acids and bases. No sound effects on this one, I'm sorry. So the learning objective for this topic is to calculate the pH and pOH based on the concentration of all species in a solution of a strong acid or a strong base. So if we're talking about strong acid and strong base in this topic, the next one we're going to talk about weak acids and bases. So luckily for y'all, this topic is fairly easy and fairly doable. So if it's a strong acid, it will ionize completely in aqueous solution to produce hydronium ions. When a strong base is dissolved in solution, it's going to dissociate completely to produce hydroxide ions. Three equations to be mindful of. The pH is the negative log of the hydronium concentration. The pOH is the negative log of the hydroxide concentration. And 14 equals the pH plus the pOH. Strong acids and bases. So there are 6 strong acids: HCl, HBr, HI, HNO3, H2SO4, and HClO4. So anything else is considered weak. So hydrofluoric acid, acetic acid, citric acid, etc. All those do not ionize completely. So these are strong acids and are strong electrolytes, so they can direct electricity. If they're monoprotic, meaning one proton, the concentration of the acid is equal to the concentration or the molarity of the hydronium ions. For H2SO4, only the first hydrogen dissociates completely. However, in a reaction with the base, both hydrogen ions will react. Strong bases, they dissociate completely. They are strong electrolytes, group 1, group 2, metals. That's what we're talking about here for strong bases, strong acids. So lithium, calcium, strontium, barium, etc. You can calculate the concentration of hydroxide using the initial concentration and the ratio of hydroxide ions in the formula. So calculations of pH. The pH of a solution can be found by taking the negative log of the concentration of the hydronium ions. So pH equals negative log, so be sure you're getting, if you see us talking about pH, pOH, got to think negative log. So what is the pH of a 0.010 molar solution of hydrochloric acid? So pH equals a negative log of the concentration, 0.010, and that equals 2.00. So remember that you see the pH number, the numbers after the decimal, that's where you get the sig fig. So according to this is 2 sig fig. So if you look at your concentration, 0.010, the 1 and the 0 at the end, that's the 2 sig figs. So if you're doing for the pOH, like what is the pOH of a 0.010 molar solution of sodium hydroxide? Same concept, pH is negative log 0.010 equals 2.00. If we're at 25 degrees Celsius, the pH and pOH of a solution will always sum up to 14 because they're derived from the K sub W, like the equilibrium constant, the hydronium concentration times the hydroxide concentration equals 1.0 times 10 to negative 14. So, like, if you think about it, if the question asks you, what is the pH of a 0.010 molar solution of sodium hydroxide? So that's where you can possibly use both equations. The first, the pOH one, and then the pH plus pOH equals 14. So here we go. What is the pH of a 0.01 molar solution of barium hydroxide, BaOH2? So we have 2 hydroxide ions, so 2 times 0.010, So the OH concentration is 0.020 molar. The pOH is the negative log of that, so it's 1.70. Now I want to find the pH, so 14 minus the pOH will give me the pH, 12.30. Find the pH of a mixture of 10 mLs of 0.00100 molar solution of potassium hydroxide, KOH, and 10 milliliters of distilled water. So luckily distilled water won't impact your add to moles or whatever, but it will affect your concentration, literally and figuratively. So the question is essentially asking, what do you need to be able to, how should I put this? We have to figure out what our new concentration is because we're adding the distilled water, and then from there we'll get the pOH and then the pH. So this is a somewhat multi-step process. It's not the worst in the world, but it's doable. Just got to know what's going on. So find the pH of a mixture. So we have 10 milliliters of 0.00100 molar solution of potassium hydroxide. So first, what we need to do, find the number of moles of potassium hydroxide that is in that particular solution. So we have, just to be thorough, so we have, where's it at? 0.0100 liters times 0.00100 moles per liter. So 0.0100 times 0.001. So just so we're clear, what we have 0.4 zeros, 2 zeros afterwards, moles of KOH. So we're going to take this number of moles, and divide that by the now total liters. So 0.0200. So we end up with 0.000, 3 zeros, 5, and then 2 more zeros after that for my molarity. So what now we got to do is find the pOH. pOH equals a negative log of my hydroxide concentration, with this, which this equals. So 0.000500, this equals 3.301. So to find the actual pH, pH equals 14 minus 3.301. The most likely will tell you that it's at, it may tell you or may not tell you that it's 25 degrees Celsius, etc. So anyway, so this is going to be 10.699 for my new pH after the fact. How would you adjust 100 mLs of NaOH solution with a pH of 12 to a pH of 11? So essentially the question is asking, how do we take 100 mLs of NaOH at a pH of 12 and make it 11? So this is another multi-step process that once you get the hang of it, it's actually pretty easy. So, however, once you get your final answer with the math, you need to make sure you answer the question. So don't just say like x equals 1,000. You have to write out a statement that says this is the answer. So first things first, what we should do is figure out probably our concentrations. But because we're dealing with pH and this is all NaOH, so you need to figure out what the pOH is. So again, writing out your steps, 14 equals 12 plus the pOH. That means your pOH is 12. Sorry, it's 12 is 2. Here we go. So the negative log of my hydroxide concentration is 2. So the hydroxide concentration is a negative log. Oh, sorry, negative log. Silly. 10 to the negative 2. We're dealing with 1 sig big technically. Well, just 2 sig bigs. So 0.010. That is my concentration. So for if I have a pH of 11, my pOH is 3. So the negative log hydroxide hydroxide is 3. To find my actual new concentration, 10 to the negative 3, 0.001 molar. So second step. So if you kind of remember from pre-AP, honors, whatever chemistry, either one, how would you adjust 100? So basically, now we have two concentrations and a volume, and how would you adjust? That means what's my new volume going to be type of deal. So this is actually a dilution question. So M1V1 equals M2V2. I want to solve for V2. So M1V1 equals M2. Oh, sorry, over M2 equals V2. So let's make our 0.010, make this my M1. This is my M2. My original volume was V1, so I'm trying to solve for V2. So 0.010 times 100 mLs over 0.0010 moles, molar V2. So I do my math, I end up with 1,000 mLs. However, remember I said that at the beginning that just because you solve for 1,000 mLs, that's not really the answer. How would you adjust 100 mLs of sodium hydroxide solution? You will dilute the original solution to 1,000 milliliters. So technically, that's the answer. So if you have any questions, please let me know. Thanks, guys.